Good morning, everyone. I'm Manoj Prassana Kumar from Singapore Telecommunications Limited. My job in Singtel is I'm the head of technology for 5G and Internet of Things for Singtel. So the theme of my talk today is going to be about 5G, how 5G is beyond a network, a true transformation of digital economy, and how app and event mesh, when coupled with 5G, can be quite transforming for enterprises. So if we see the evolution of telco networks, the evolution started from 1G in the 1980s, where 1G was all basic telephony. There was no mobile broadband back then. And 1G quickly evolved into 2G in 10 years in the 1990s, where people started to talk about latency, but still latency was about 1000 milliseconds. And the download speed that people got was about 40 kilobits per second. And when 2G evolved into 3G in 2000s, early 2000s, this was the era of the early mobile broadband, where people started to see mobile broadband speed of up to 20 megabits per second in their handsets. And when 3G evolved into 4G in 2010 and beyond, this was a true era of applications where mobile broadband became much more faster. Latency started to get smaller and smaller, and people started to observe latency of less than 25 milliseconds in their handsets and speed of about 100 to 200 Mbps in their handsets. And here we are in the era of 5G in 2022, where people expect a latency of less than 5 milliseconds, and enterprises have an expectation which is very aggressive. They expect less than 1 millisecond, especially with the ability of deploying 5G in a private form inside the customer's campus with campus networks and so on. And 5G is going to be applications on steroids, devices on steroids, because the low latency and high throughput that 5G can offer is going to enable more and more applications, more and more use cases. In 5G, there are three major enablers of the network. This is what you see in the right side of the picture. The first enabler is massive mission type communications. 5G can support much higher connection density than 4G. And this becomes a true enabler of verticals like smart cities, smart buildings, smart enterprises, and so on. And the next key enabler of 5G is ultra low latency communication. And this is very key, especially for use cases like drones beyond line of sight, autonomous cars, where there are a lot of devices making autonomous decisions. And it is very important for such devices to reach their backend applications in as low latency as possible. And the third, but not the last enabler in 5G is an enhanced mobile broadband. So this is a key enabler for high throughput applications. Example, 4K video streaming, 8K video streaming, 360-degree video streaming. And this is going to transform the entertainment industry as people will get much richer and much deeper content, especially in a high throughput manner where they don't see any lag between the actual time when the event happens and the time when they are actually consuming the event in their handset, when they view the video in their handset. While 5G is going to be a foundation of a lot of devices, a lot of applications in the near future, if we see what enterprises are doing, how enterprises are thinking, especially as 5G is enabling more devices and more applications, customers think in three lenses. The first lens for a customer is what are some of the technologies that could be business enablers for them. Customers constantly think, how can they create new line of business? How can they be more profitable in their existing line of business? The second lens that customers always look at technology is productivity revolution. What type of technology can they adopt to improve the productivity of their workforce, to improve the productivity of their business, and which helps them to become less cost efficient? And the third lens that customers always see is interfaces and experiences. What type of technologies can transform their end customers' experience, the way they interact with the business, the way they interact with the applications? Now, if we plot all the upcoming technologies that 5G is going to enable in the near future in these three lenses, and if we see how these applications are going to evolve in the short term over the next 1 to 3 years, in the medium term over the next 3 to 6 years, and in the long term, next 6 to 8 years. So a few examples that I would like to quote. If you see a key business enabler, smart contracts and blockchain come as a very key enabler for many businesses. Let me give you an example. All of us have insurance policies, be it health insurance, be it travel insurance, be it insurance for our cars and so on. The insurance industry is quite actively exploring blockchain to automatically extract data about driving patterns, about health of an individual, to arrive at spot pricing, especially if, say, for example, we are traveling in a different country, we are trying to rent a car, and then we are trying to get insurance for the rental car. Insurance companies are exploring ways to use blockchain to gather data from different other critically adjacent verticals like healthcare, your driving patterns from your OBD devices in your own cars, in your home country, and so on, to determine the spot pricing. This could be very cost effective for consumers because for consumers with good driving pattern, with a healthy physique, they will get a much better insurance cost, especially when they travel. And this also mitigates risk, especially for bad drivers. The insurance companies can mitigate risk by pricing the insurance at a higher cost for them because they have a data-driven way of deriving the spot pricing using blockchains. So this is seen as a key enabler, as an example in the insurance industry. Likewise, if we see an example of technology being a productivity enabler, or a technology that revolutionizes productivity for an enterprise, Edge AI can be an example. So in Industry 4.0, many companies, many customers are exploring video analytics quite actively, where they are transforming their existing CCTV cameras to have video analytics at the edge, to be able to identify products which are having manufacturing defects. Because for such companies, if they identify products with manufacturing defects at the assembly line itself, it saves a lot of logistics cost for them. Because if a faulty product reaches the hands of a customer, the customer is going to return the product and then they have to ship a replacement product. So it is 3 times the cost of logistics for a faulty product to reach the hands of a consumer. So Edge AI is being looked upon quite actively to ensure that the assembly line has products with no manufacturing defects, and it also ensures other aspects like workplace safety, worker health compliance, and so on, more from a government regulatory compliance perspective as well. And from interfaces and experiences lenses, computer vision and digital twins are quite actively transforming a lot of verticals. Now, no customer who operates multiple estates is wanting to invest heavily on manpower. They want to invest in technology, where they want to invest in cameras, connect all their cameras to a single digital twin, and customers want their security teams to sit in front of an operational center and operate the entire campus or multiple campuses in a completely digital fashion. So these are examples of what lenses customers are looking at transformation and what technologies are actively enabling those transformation. If we take a bunch of these use cases that are transforming a lot of verticals, be it video analytics, be it drones, be it autonomous guided vehicles, be it 4K, 8K streaming that revolutionizes the entertainment industry, all these critical use cases have a common denominator. All these use cases, they require high throughput because they are constantly uploading data. Can you imagine an autonomous car with 8 or 10 cameras driving on the road? How much video it generates from all the 8 or 10 cameras, and how much video has to be processed from all those 8 or 10 cameras to make a decision on when should the car accelerate, when should the car brake, when should the car have a speed of 30 and 50 miles per hour, and so on. So such use cases which are having a high throughput requirement also have a consistently low latency requirement. Can you imagine a drone being piloted by a remote pilot, and the drone is beyond line of sight, and the drone having a latency issue, and it receives the maneuvering commands from the pilot 5 or 10 milliseconds later? That 5 or 10 milliseconds delay is good enough for the drone to even hit an aircraft. So these are mission critical use cases that you see within the yellow box in this slide. And all these use cases, the common denominator is they need high throughput and they need low latency. And this is exactly where 5G becomes a key enabler for such use cases. And if we see what each of these use cases also brings into the market is devices. So a funny analogy, human population is growing at the rate of 371,000 babies being born every single day globally. But if you see how many handsets and devices are being born across the globe, is more than twice than the human population. So there was a research study which says there are about 700,000 Android devices that are activated per day, and there are about 562,000 iOS devices that are activated per day. These are new devices coming into the market every single day. No wonder the handset makers are making a lot of money, but these devices are increasing every single day. two or three times more aggressively than the increase in human population. And if you see where is the end game for these devices, Internet of Things in the next 3 to 5 years is expected to have about 50 billion connected devices globally. And these devices enable a wide variety of use cases. Like, for example, the device can be as simple as a smart smoke detector. It can be a camera, it can be a robot, it can be a drone. But each of these devices connecting into the network generates a lot of data. And when customers own a lot of these devices and customers own a lot of these data, they definitely want to make data-driven decisions. So these could be towards automation, these could be towards operational efficiency, or these decisions could be increasing profitability. No matter what the use cases, customers have a constant need to gather all data from these millions and billions of devices that are being connected onto the network and make data-driven decisions. This is where a data mesh and an event mesh becomes a very critical aspect for customers. In spite of having highly capable networks like 5G, they still want a data mesh and event mesh that can seamlessly connect their applications to their devices in a multi-protocol fashion. So then they are not locked down to a single protocol. So then they don't have any technical limitations on what kind of devices, what kind of data they can adopt. And if you see a typical enterprise, right? So the picture shows a typical work office environment, a typical enterprise office work environment. This can be a bank, this can be a technology company, any type of an enterprise. If you see how many devices such an enterprise is deploying today, example, for meeting rooms, they have meeting room booking systems, they have audio video control equipments, they have people presence detection equipments, they have wayfinding equipments, and they have visitor management equipments, printing badges, and they have smart lockers. They have like COVID management devices, like for example, temperature screening device, hot desking sensors, and so on. Right? So you can easily imagine an enterprise who has like a 6 to 8 floor office to have like easily about 10 to 20,000 devices that are deployed inside their enterprise. And what are all these devices going to do? Right? Is unimaginable. So these devices are constantly generating data. And analysts say by 2025, 153 zettabytes of data are going to be emitted from these 50 billion devices that are going to be connected in the network. And can you imagine the art of possible with this 153 zettabytes of data? Enterprises are very excited about the possibility to monetize this data, about the possibility to get more and more efficient, more and more automated with this data. And there are 3 aspects that is required for any enterprise to be successful in their data monetization strategy with all these 153 zettabytes of data that's going to be generated. The first and foremost aspect that is required is definitely a reliable network that will connect these devices to the backend applications. And the second aspect, even though there is a reliable network, still they need a mechanism, a generic mechanism for them to tap data from any device, for them to transport data to any application. So this is where a data mesh and an event mesh that can scale to the tune of handling 153 zettabytes of data becomes very important. So it is that combination of a reliable network plus a scalable data and event mesh, which is what will be a foundation for customers to start collecting as much data as possible and customers to start processing, analyzing, and making data-driven decisions. And last but not the least, customers also need a lot of applications that can sit on top of this data, that can make business-driven decisions based on the data insights that these applications can get in order to kind of like make the enterprise as real-time as possible. So this is what customers are constantly looking for. And these are the 3 key enablers that will help a customer become very successful, especially when they have so much of data to handle. And if you see what enterprise customers are expecting from carriers like Singtel, right? So they expect 3 things. With 5G, they definitely want a lot of data-driven automation. Every customer is buying sensors almost every single year. They're deploying sensors to make more automatic decisions. And these could be common life examples, like with COVID, now there are a lot of safe management. So customers are buying video analytics technologies to see if safe distancing is practiced meticulously inside buildings, especially indoors. A lot of customers have implemented hot desk because now they have team A, team B set up in work environments and so on. Right? So customers want more real-time decisions these days, especially as the COVID situation is transforming the business environments, work environments of customers every single day. The second aspect that customers expect is assurance of performance, assurance of their experience. They don't want their devices to go down because of battery issues. They don't want them to not have any visibility on their devices because the network is down. Likewise, they don't want to have any missing periods where data from their devices is not available because the data mesh couldn't scale or the event mesh couldn't scale. So assurance is something that every customer is asking for whenever we go and present upcoming technologies like 5G, IoT to such customers. And customers are constantly looking for innovation. So they're looking for new use cases that they can implement that will transform their respective line of business. They're looking at new ways of running existing business. Customers constantly want to think out of the box, execute out of the box. And this puts the pressure in customers in having a need to constantly look for new types of devices that can give them as much granular data as possible, and new type of applications that can present that data in innovative fashions to them that will help them make decisions that will change the way they work, live, and operate their business. And if you take a typical industry, right, what type of devices are there in an industry? The picture shows you a typical warehouse, right, where you see a lot of autonomous guided forklifts, right, where the forklifts are cranes which carry goods inside the warehouse. These cranes could be operated remotely by a remote driver, or it can be like a driverless AGV as well completely. There are workers going around the factory. Each worker has sensors to monitor their health, to monitor the compliance, to also report where is their location within the factory floor to whoever is assigning job assignments to them. And there are temperature sensors, there are smoke detection sensors, there are video cameras, right? So each of these devices, if you see, they do a totally different type of a job. For example, the sensor that a human wears as a smartwatch is monitoring his health, whereas a camera is continuously uploading video of whatever environment it is doing surveillance on to a backend application. Right? So with all of these different types of devices in each vertical generating a lot of data, what are the needs for any upcoming application, right? Like video analytics, virtual reality, metaverse, and so on. Right? There are 5 major needs that any application will have. The first one is the application certainly needs high-speed data transfer between the devices and the users. The applications expect a lot of powerful compute, right? Almost there are no modern application that doesn't require a GPU these days. And this is an example of how compute needs are increasing for applications. And end-to-end ability to scale. Application wants the network to be scalable. It wants the data mesh to be scalable. The application wants the compute infrastructure on top of which it is running to be scalable. And when I say scalable, is scale up and scale down depending on the usage patterns. And reliability, definitely every customer expects reliability, and end-to-end customers also want security. And if you look at the behavior of these devices, right, each device behaves in a different way. For example, a smoke detector only sends heartbeat data. It only sends once every 2 minutes or once every 3 minutes whether there is smoke in whatever environment it is monitoring or whether there is no smoke. Right? Whereas a video camera is constantly uploading 4K video, 1080p video, full HD video, and so on to backend applications. These applications could be digital twins and so on. Right? So the behavior of each of these devices in the network is totally different. And if you take few of these examples, right, not just the behavior of how they upload data, but also whether they are stationary or whether they are moving around. For example, a surveillance camera can be quite stationary, but it needs yet high uplink because it's constantly uploading video, right? Whereas an edge camera, which is capable of doing face recognition, license plate number recognition, speech to text, text to speech type of cameras with a bit of intelligence, probably they consume lesser uplink than dumb cameras because they do a lot of processing at the edge. On the other hand, if you take cameras mounted on drones and cameras mounted on robots, these are constantly moving, which means irrespective of which location they are in, they still need to maintain the same quality of experience. They need to maintain the same level of high uplink capacity that they need. And the data mesh or the event mesh that connects these cameras to the backend applications should also be capable of handling mobility, which means the event mesh should in no situation say that, okay, I'm not able to reach the camera because the camera is in a remote location where I don't have connectivity. So this forms the foundation of the need to couple the data and event mesh with network slices in 5G. So 5G enables this fantastic feature called network slices, where a telco can slice a physical 5G network into multiple logical slices. For example, there can be an IoT slice where all devices which exhibit heartbeat pattern, right, which only upload like one or two events, say for example, between a minute or two, which consume very low quality of experience, low resources in the network. So for such devices to be able to connect to the IoT slice, whereas mission critical devices like video cameras, mission critical devices like VR headsets, right, where customers are using for remote training and so on, can be connected to like a high throughput slice. And first responder equipments, right, like say for example, police, ambulance, they can be connected to a mission critical slice, right, where they have complete high preference, high priority because they're saving human lives and they are absolutely mission critical for any country. Right? So if the event mesh can be coupled with the network slice, for example, the event mesh in an IoT slice consumes less compute, less resources because it's only carrying IoT data. Whereas event mesh inside a mission critical slice is consuming as much powerful compute as possible, and it is ready to scale anytime because it is supporting mission critical devices, mission critical applications. So it is this combination of event mesh with a network slice, carefully controlled on the network quality of experience, that this combination can enable for a vertical, for an application. It can be quite transforming for customers. And what is the end game with the event mesh connected to a network slice, right? So there are three types of deployments that typically an enterprise customer can do. One is customers prefer to do edge deployments at their campus, where customers put edge compute servers, telcos deploy campus networks, we build private radio on their campus. So these could be examples like the defense, like the police force and so on, where they have their own private network at their campus, where we deploy compute at their campus. And if the event mesh can sit on campus at their premise, which connects their devices to their applications, especially under different network slices. Even within enterprise customers' campus, there are different types of devices. There are smoke detectors, there are video cameras, there are AR, VR headsets, and so on. And each device can be on a different slice depending on the quality of experience that the device wants. Right? So if the data mesh or the event mesh can sit in the customer's campus, coupled with the network slices, can be quite powerful, can be quite compelling for a customer. And the second type of the deployment that is possible in the market is customers deploying at the telco edge. So every telco is building edge compute infrastructure called MEC, multi-access edge compute, which is compute and storage at the edge of a telco's 5G network. And many customers who have mission critical applications, especially applications with devices roaming around the country. You can imagine use cases like drone swarms, autonomous cars, online gaming, where we don't know where the device is going to be located physically within the country, and the devices can be constantly moving. For such use cases, it is the telco's edge that can be quite compelling for such use cases to host their applications, because a telco has multiple sites across the country, because telcos power the cellular network for the entire country, and applications can be connected always to the closest edge location, offering the low latency that they expect, especially less than 10 milliseconds. And the third type of deployment typically can be a public cloud deployment, where customers go and adopt hyperscalers like AWS Azure to deploy their applications. And what makes the applications always to be connected with their devices is the network that can extend from a customer's campus all the way to the public cloud. And if this network can be tightly integrated with the event mesh, where events can be carried from any of these devices to any of the infrastructures. Say, for example, a customer like the airport, right, where they will have private networks, they will have private devices inside their airport campus, and there could also be devices roaming outside the airport campus, especially on cargo areas, on maintenance areas, and so on. And there could also be less mission critical applications that are offloaded in the cloud to manage cost. Right? So if the event mesh is stretched from the customer's on-premise edge all the way to the public cloud, and there are multiple virtual slices of the event mesh coupled with 5G network slices, can be a game changer for a lot of industries, because this will help industries adopt cost-effective deployments, especially if their applications are not mission critical. They can always go to the public cloud. If the applications are very, very mission critical, they can adopt for a high throughput mission critical network slice enabled with a highly scalable event mesh, which can jointly ensure that the customer's applications are always connected to the customer's devices. So it is this hybrid event mesh coupled with 5G network slices spanning across the edge all the way to the cloud will be the enabler of a lot of data-driven industries in the near future. Now, keeping in mind that 5G, when coupled with an event mesh and when coupled with infrastructures like the edge and the cloud, can enable a lot of these devices and applications. This is a foundation on top of which a lot of next generation enterprises are going to sit very soon. And this foundation of event mesh coupled with powerful networks like 5G can enable a lot of new businesses for a customer. For example, whichever domain a customer is operating on, the data that they collect, they can start monetizing that data as a product. Can you imagine a fintech company trying to monetize the data that they get in an anonymized fashion with retail industry, trying to give targeted advertisements to consumers? Likewise, a healthcare vertical sharing anonymized data about disease spread trends to health insurance companies, so then they are better prepared, right? So enterprises can embark on data as a product, and enterprises can become domain owners of their data, where other domains, critically adjacent domains, can contact this enterprise through digital technologies like blockchains to validate data, to validate records in a real time. So these are a few examples of what type of data-driven new business lines that customers can create, especially when they're sitting on a scalable foundation of high-performance networks with high-performance event meshes. So the key question is, as an enterprise, are you ready to embark on this transformation? Are you ready to monetize on the data that your enterprise is gathering? Thanks a lot, everyone, for patiently listening to me today in how 5G and event mesh can be a powerful combination for enterprises to do a lot of digital transformation.